So now I think let's catch your time. We will start the Team 5. So Team 5 is the Hong Kong University of Technology and Science and Technology, UST. So now you also have 8 minutes for the presentation. Thank you.
Hi, we are Team Pixory from HKUST. And let me start by painting you a simple picture. Imagine you're an engineer building the next big thing. Maybe you're building some sort of a rocket or the next big internet company. And you start building it by opening CAD. Or maybe you open Figma. And you spend the next 50 hours designing it just so you can spend another 50 hours prototyping it. And then you realize that you've just wasted most of your time because what you've designed is something you designed long back for a different project or maybe a scrapped project. And you're not alone. Research shows that 90% of all design activities in UI/UX contexts are based on variants of existing designs. So to find out whether it's irrespective of engineering streams, we conducted a survey of 10 mechanical engineering students across undergraduate and graduate years. And we found out that every single one of them have at some point duplicated their work while doing CAD modeling in their career. So let us segment the issue in 3 parts. The first is manual rediscovery, which is the act of sifting through past designs, actively trying to search for something visually similar to what you're designing right now. The second is high-friction metadata tagging, which is attaching information to elements or parts of your design. And the third, which is quite abstract, is artist retrieval. That is, it's finding designs that may be visually or semantically similar to the design you're currently working on, but also they may have different aspects, such as designer's choice or intentions, that any sort of design tool or storage tool cannot encapsulate. So to solve these issues, we say that there exists no solution to allow effective and efficient searching through past designs. And so we introduced Pixory, which is a plugin that integrates seamlessly with all your favorite design apps. For the purposes of our prototype, we've kept it simple and selected UI/UX designs along with 3D CAD modeling by supporting Figma for UI/UX and AutoCAD for 3D modeling. This is our solution. As you can see, Pixory understands your current canvas and it suggests recommendations in an in-app pane. Pixory can also read and understand your past designs, part of your design library. Pixory suggests the most similar designs from your past library by conducting UI similarity search visually for both 2D and 3D models. And you can also apply those design elements by just a single click of a button. The next part is artist retrieval. As I said, existing tools cannot record the designer's choices. Every single design choice is intentional, and that leads to loss of reasoning and insight. Because when you import a design that you worked on years ago, you don't understand why you did something. There are noticeable changes. And that's why we provide a context graph. Users can choose to identify any useful context through the context menu, and they can provide the context in natural language, similar to documenting code. We can also use these design choices and understanding your reasoning to then provide even smarter suggestions to you that visual similarity search just cannot encapsulate.
Hi, everyone. I'm going to be walking you through the technical side of this. So when you look at this UI element, when you look at an app screen, you don't just see individual buttons and text boxes, right? You see groups of things, like a drop-down menu or a navigation toolbar, right? And that's exactly what we think that our model screen parser also does, what we believe it does. So the first part in it doing so is that it uses a faster RCNN to scan all the elements on the screen, and it builds a sort of coordinate system for each element on the screen, right? And it sorts it based on where each element on the screen is, and then it passes that onto an it treats the UI as a sentence that needs to be parsed. So it passes that to an LSTM neural network, which essentially outputs a tree-like structure. You can understand this structure by likening it to maybe a syntax graph that other language models produce. So in short, it basically doesn't just see the UI, it understands the structure behind it, right? And a similar thing is happening for the 3D part. It tries to, suppose you have a complicated 3D geometric shape, right? Like a chair or something. So it tries to reconstruct that chair using smaller primitives A primitive is nothing but just a simple 3D shape like a sphere or a cube or a cylinder. So it tries to reconstruct the complicated model using these simple, smaller shapes. And so in conclusion, both of these models do a similar thing. They try to understand the data. They understand the structure behind something using only flat data, like an image or a screenshot of a screen.
So we're not just trying to solve a small annoyance. This is actually a major industry inefficiency. And according to our preliminary market research, we found that we identified that our TAM is the AI-powered design industry, which is worth 27.5 billion USD. This is the absolute ceiling of revenue we can pull in. Narrowing down, we have our SAM, and we position ourselves in the design asset management industry. This industry is currently booming because of AI leverage, and it is currently valued at $8.7 billion. To keep our estimates as pragmatic as possible, we only want to capture 1% of the SAM, which boils down to $87 million. Our business model involves the use of two tokens. So there's pixel tokens and CAD tokens. Since our plugin supports both 2D and 3D design, we make sure our users don't feel like they're getting scammed out of their credits. People have monthly balances, which refresh every month, and after they expend all their tokens, we charge them on a per token basis. In order to further incentivize the upgrading of tiers, we have the teams and enterprises packages. And personally speaking, I think for freelancers and young companies, starter is adequate enough. But if your retrieval requirements are more compute intensive, feel free to upgrade to teams and enterprise.
For our main competitors, we wouldn't call them the competitors per se. We would more likely refer them as people who do, the products do similar things compared to ours. We will start off with the first one, which is Figma AI, which is a tool that attempts to perform UI similarity search, similar to how we in Pixory do it. However, for Figma AI, you do have a hurdle of doing active searching, which means you need to find the keywords in order for you to find the specific UI that you want to make. Next up, we'll talk a bit about UX Magic and UX Pilot. UI Pilot is more about going to a certain website and trying to know how to navigate through the website such that you will get to the page that you want. And UX Magic is more about powerful high-fidelity UI cloning and design. Next up, finally, Soya AI. This is the most similar one compared to ours, which is they make 3D model metadata software, which means they already have the hierarchy of the 3D models that they already have. Now, moving on, we would like to take the best of these three different worlds of generative power, task automation, and technical metadata, and we would like to combine them all into Pixory, which is a design memory. Next up, we have our team, and yeah.
Thank
you very much.
The time is up. Thank you very much. So now we'll pass the time to the judges for the 12 minutes Q&A session. Thank you, judges, please.
Thank you for the presentation. I think it's a real problem that you're trying to solve here. I've heard different ways to solve that problem. One of the key challenges, however, is you mentioned flat images and those that AI generated in particular through diffusion. Basically, there's no layering. So you have an image with multiple objects on it that cannot be isolated. 3D model is even worse, right? So how do you solve that problem with effective references while you can metadata it, you can find it, but you cannot really use it because you cannot layer the flat image so far, right? I know company only solving the delayering problem, and yet you're solving a bigger problem. How do you do that?
That's a good question. The first thing for the software we're using, Figma, it is a UI design software, so it provides what we like to call, as you said, layers. So it's an SVG software, so as you make designs, you actually add objects and different elements onto the layer, onto the sort of canvas. So every single software has different sort of ways they do something like this. For example, AutoCAD also has their own version of layers, which is objects. And it becomes much easier when we use those objects rather than screenshots, because as we talked, we are currently using screenshots. We would like to use those sort of the layers that those software provides. But the issue or the challenge becomes that supporting multiple different softwares, because there's Sketch app, Adobe XD, etc., just within UI UX. Supporting all of those becomes a big challenge because we have to generalize our backend. So I think that's a good problem you've mentioned. And what we would rather try to do is have a mix of both the sort of flat image data, because in a lot of cases, the predicting with flat images, like sort of much simpler layouts, is very easy. But at the same time, when you have much more complex layouts, you may need those layers from, like, say, let's say Figma's API or AutoCAD's API, where you can actually extract individual elements. So I think that's how we would tackle it, with a mix of both.
Similar question. Every design is to solve a problem, right? So you can actually have a database of all the design, and then, as you say, most of the design is actually repetitive. That's from the design perspective, from the output perspective. But in terms of the problem, it may not be the same problem. So do you have do you have to match the problems to be solved?
I think the way we have positioned it to be is because we're all designers in some way. We have mechanical engineering experience and both CS experience. So what we've rather noticed is that while yes, every single design solves an individual problem, we don't solve repetitive problems. While solving a problem, there's only one or two insights that actually separate one problem solution from another problem solution. You may use one solution generically in multiple problems, but there's different aspects or different insights that separate the solutions. So that's why what we've done is we want to support human creativity and ingenuity, and that's why the repetitive tasks of finding things and not making new knowledge again and again, that's why we're making this. So you spend more time finding those actionable insights and finding those key points that separate the solutions. So I think that's how I would position Pixory to be.
Thank you for the presentation. I think the ability to gather all previous designs, and especially the reasoning on why a human made a specific design, is very powerful. And currently, your product's function is search and retrieval, right? That's the first step. But obviously, I think the potential could be more. You mentioned, I saw a slide that had generative power. So could you just lay out your product roadmap for us?
Yes, we had a roadmap slide, but due to the time constraints, we weren't able to present it. In fact, when I evangelized the product, when our team was thinking about it, we realized that, yes, in fact, knowing all this data, knowing designers' choices specifically, as I mentioned, context graph, I wasn't able to go too deep into it, but to know how and why designers are thinking and their thought process is extremely powerful. So what we intend to do is not just search designs for them, but by knowing how designers think, we want to aid them in their thinking process. I think a lot of people usually use LLMs for thinking aid, and that is one way to go about it. But designers can't just use LLMs generally, because LLMs are very generic. They answer questions in a generic manner. They don't have domain expertise. And then having domain expertise, LLMs cost even more money. So I think by understanding, and over the course of time, by training our model, we'll be able to build and develop sort of a better assistant for designers. So when they're thinking about their designs and their design choices, they'll know why and how something is happening. Another point I want to add is we want to support other streams of engineering as well, specifically electronics. Circuits are another big case where there's a lot of repetitive work going on. And in fact, circuits use abstractions. They use different sort of chips and boards that are already implemented by someone else. So I think that's somewhere where we can integrate Pixory as well. That's sort of our roadmap for now.
So it's not extremely backwards compatible, because CAD designs 10 years ago, people don't necessarily annotate their reasoning. So going forward, how do you capture that? Yeah.
So as I presented earlier for the Figma plugin, we have the ability where you can in natural language add reasoning, and because they don't have annotation in the documentation from earlier from in the past, that's why we cannot currently, as I said before, make that assistant. To make that assistant, we need a lot more data. That's why I think over the next sort of course of time, as people start using the product, because again, we have first mover advantage, there is no direct competitor who is doing something similar. So because of that, we'll gain user base, and as users start documenting, because they'll realize the importance of this, of annotating and documenting the project. And every single design has a set of specifications associated with it. So they will naturally probably just copy the specification, or they'll sort of document their thing, similar to how we document code. They'll start doing that, and over time, we'll sort of build that database, that context graph that we can then use.
Right, thank you, Justice. Thank you very much. Thank you, Hong Kong USD, for the presentations.